Okay, so let's start. So thank you everyone for joining us today and coming on time especially. So I'm Kaijin and I'm the BD manager at TechTown. And today I'm glad to introduce Assist on Mastercam, and this is a webinar co-organized together with CloudNC. So today I'm very honored and glad to have Geoffrey joining us all the way from London in this morning. And okay. Yes, so Geoffrey is the Senior Product Manager at CloudNC, and today he'll be with us for the first hour to introduce Assist, to conduct the live demo of the product, and lastly, have a Q&A with all of you if you guys have any questions. So after that, at 5 p.m., TechTown side will follow up with the next steps with you all, share with you all the sales-related questions. And we hope to be able to end by 5:15. But of course, our team will stay until 5:30 if you guys have any other further questions. I hope you guys can hear me properly. Okay, so if all of you can hear me properly, you can actually use the react button also. Okay, but otherwise, let me continue. And before I start with the event, the webinar itself, let me just do some housekeeping, some things to take note. If you guys have any questions, do feel free to leave your questions within the Q&A segment, if you see on the top of your Teams. And if you guys find it's too difficult to type in your questions, you can raise your hands and then we'll allow you to unmute yourself to ask your questions. And of course, it'd be good if you guys can turn on your video also so that we know who we're actually talking to. And in terms of the questions, we'll prioritize the technical questions first, since we have Geoffrey with us today, and we'll leave the sales-related questions to the end after 5 p.m. And if you guys see any questions within the Q&A segment that you find is relatable and you want to get answered, do upvote it during the course of the event itself. And if you look at it now, you can actually see some of the pre-submitted questions that has already been submitted, and you can click on them and upvote them as we go along with the presentation. Okay, so do also note that this webinar will also be recorded. Okay, so without further ado, let me just start with introduction of our TechTown company first before we move on to Assist. So a brief overview of TechTown. We've actually been serving our customers for over 30 years. We've been helping to optimize CNC machining through the solutions we offer through the Southeast Asian region. So why do we do what we do? Of course, our vision is to empower the future of manufacturing in Southeast Asia. How do we do it? By empowering our customers through our exceptional manufacturing solutions, where we hope to drive improvements in your safety, productivity, precision, and cost effectiveness. So what are the values that drive our team? Customer obsession, empowering growth, and trusted partnership. And today, I'm glad to celebrate our first and our new partnership with CloudNC, whereby we can help to empower our customers with the new AI CAM programming solution. A brief overview of our solutions that we carry, the brand products and the services product. And of course, today we are adding our CloudNC as a partner to Assist AI CAM programming into our product line. And other than that, our services, we also offer maintenance, training, and support. Okay, so let me not hold up the time from the webinar itself, and let me introduce Assist for Mastercam to all of you.
Assist, which means, hey guys, Theo from CloudNC, and I've got good news. AI has now come to Mastercam, thanks to CloudNC's CAM Assist, which means that the world's most popular CAM package and the most popular package in the US, which hundreds of thousands of machinists use to produce parts for every great American industry, oil and gas, defense, automotive, aerospace, you name it, now get to access our machining AI. It took us 9 years to build it. It's built specifically for automating the process of making parts like this, meaning that you can spend the time that you save on the things that actually get your spindles turning, the things that actually win you more business. Because Cam Assist can make you up to 5 times faster by removing the tedious, repetitive, busy work that comes with CAM, that comes with estimation. So if you want to get started with our machining AI today, all you've got to do is Google CloudNC and speak to one of our machining specialists, and we can get you set up with this AI in hours.
Okay, so lucky for all of you here, we don't need to Google CloudNC because we have Geoffrey here with us. So without further ado, let me pass on the time to Geoffrey.
Thank you, Kai. I'll start sharing here. Pick my screen. All right, so I'll just continue on to what Theo was saying in the video there, give you a little bit of an overview of CloudNC. So we've been in business about 9 years. We're venture backed at this point. We've started to sell Cam Assist, our AI product, a little over a year ago. And we started in Autodesk Fusion, and now we've been in Mastercam since July of this year, and we're also in Siemens NX, and we're about to launch into some other products as well. So our software, how did we spend 9 years building it? Well, we were basically building up from the ground up a new form of AI for machining and training the machine system to understand how a machinist works and how a machinist thinks. So our AI is really built on the core principles from physics modeling, and then using our own statistical and probabilistic models and inference models that we've developed to bring this technology to the market. So our goal and our vision is really to empower lights out manufacturing and have single people being able to build businesses and entire factories with minimal human intervention. So like Theo was mentioning, Cam Assist lets you automate a lot of those mundane and regular processes that you do in CAM programs like Mastercam. So it takes some of the drudgery away from that work, lets you focus on some of the high value jobs while you're doing other things. It also empowers you to leverage the power of CAM for doing automation and estimation. So this is a view of our cutting parameters explorer. I'll get into that in a bit more in the demo here, but our model is not a database. It is a physics model that's dynamic, and we'll show you how that all works together. And then when you bring that in with other tools like our fixture management, which I'll demonstrate here, you'll see that the value is really brought to the user in through a variety of techniques and features that help to automate and improve the process. And then, like I was mentioning, for using the CAM program for estimation, we've had customers when we initially started to sell Cam Assist that were only doing estimation. So they sent out 20 or 30 quotes for every job they actually machine. So the time taken to do this step is really important and a drain on their system. It's a drain on their CAM programmers. So we've brought in an estimation feature into Cam Assist so that you generate the CAM program and then use that CAM program to provide the cycle time estimates back out as an output. So let's jump into the demo. Get Mastercam going here. So I've got two parts. We'll start with this one. So this is quite a basic part. I've got it set up in work holding in my vise here, and I've got two operations. So in Mastercam, we define the operations in the machine group. So I've got that set up already. All that we need within those machine groups is a master model and the stock setup and the fixturing. So that's all ready to go. So I will go up to the ribbon here. You can see that Cam Assist is an add-in for Mastercam. We'll open that up come to Cam Assist. Just going to say that it's going to save my file. And then I'm just going to authenticate in. So the login process is independent of your Mastercam login because it's a third party. And now we've got the Cam Assist panel open up here. So the first thing I'll do is I can pick my tool library. So I can pick up to 5 tool libraries. So if I have my libraries organized by material or by application or by vendor potentially, I can bring in more than one of those libraries and merge them together when I run Cam Assist. I can run in 3-axis or 3+2. This part has some holes on the side here, so I'm going to run with 3+2. I'm going to pick this first option. I would my setups for the top and the bottom for my machine groups, and then in the tool use tab here, this is how Cam Assist is reading the tool DB file or the tool DB files if I had more than one. So we're bringing in tool assemblies because we get better results and more safe and collision-free results, of course, with the assembly. That's the tool plus the holder. And then we also have our selection of materials here. So we can pick from these materials, and each material has a set of alloys. And these are all alloys that we've got in our cutting parameters. So when I say cutting parameters, that's our system for defining and calculating the feeds and speeds directly from the parameters and the variables that are attached to the file. That's including everything from the material that we're going to be cutting to the tooling, to the machine properties, and a bit more. So we can use those to calculate, and we can also predefine. So if I want to run on my machine with my own feeds and speeds, we can run those with what we call presets. And you can see on this toolpath here that I've got some presets defined for aluminum. We run through the following toolpath types, from face milling through to deburring, and I'm going to do the full part. So with all of that set up, I'm just going to hit run. So when I hit run, we're called CloudNC because this is the cloud computing process. We're leveraging the computational power of cloud computing for this calculation, because our AI basically, it's examining the whole part geometry within the constraints of the selected tool libraries and the work holding, and it's breaking down the part as a machinist would. And it's not doing feature-based machining, which you might be familiar with in Mastercam. It's actually doing the whole part geometry and examining the millions and millions of possibilities based on what the tools it has available, and then it's creating its own set of strategies, Cam Assist set of strategies. And those strategies will then be mapped back into Mastercam. As we map into, say, roughing, we create roughing toolpaths. So you can see now on the left that the toolpaths are coming in from the cloud, and they're coming in dirty, which is fine. And we're going to have 54 operations coming in for this part. There's going to be more operations in the tool groups, the toolpath groups that are defined, because we do add some stock models when we do roughing. And we use the roughing stock models actually to compute the next step in the roughing process. So basically, Cam Assist takes the part from the finished state, breaks it down into see all of the different elements of the part back into the roughing state. So I mentioned estimation before. You can see here that I can run a cycle time estimation for this part. I'm going to hit yes here. So what that's going to do is then tell Mastercam to please generate the toolpaths. And so this will take a few moments. Of course, we've thrown a few dozen toolpaths at Mastercam all together. So it's going to calculate through those. So now CloudNC is essentially finished. And what we're going to be doing is taking the calculated CAM program, and we're using the backplot time from each toolpath to generate a report, which can then be used for your estimation or internal planning. So we'll have a look at that once that's finished calculating. So basically I've clicked about 4 times to get to this stage, and now I'm just waiting a bit on Mastercam to calculate. Of course, with Mastercam, this means I could be doing other things. I could have another session of Mastercam open in another window, or I could be doing other things on the shop floor. I'm going to try to get up to the top here while that's calculating. So I mentioned the cutting parameters. So let me try to get, it lets me click on one of these toolpaths. Not quite, we'll have to wait a bit, but maybe we'll just have a question. So what are the ideal applications for Cam Assist? So looks like we're done now, but just to answer the question about ideal applications, you can see that high mix, low volume is really a sweet spot for Cam Assist at the moment. We are a precision manufacturing solution, and we're bringing more and more of those capabilities into the system over time. So basically, we see our place in the market is going up into higher and higher precision, higher complexity of parts, and more complex industries as we go forward. So this is the cycle time estimation view of the initial view. So I had an existing run in my queue. So what this does, it means that I can stack up files. So if let's say I've got 4 files from my customer and I want to estimate each one, I can run them through in a bulk process in the cycle time estimator. But I can also do it the way I just did here, one by one. So it gives me a bit more control over the outputs. And then I could take those outputs and export them out. And let's say on the part here, I'm not going to generate the report for this one, but I'm going to do a dozen of these parts, and I want the setup time to be, let's say, 300 seconds. I need some time to set up the job. I have a scaling factor here to compensate for the variability between my backplot time and what actually happens on the machine, and then I can export that out. So those results get exported out into the folder I specified there, and maybe I'll set up a different one so I can find it. Put it on the desktop. So we'll take a quick look at that. Come back to the webinar here. It's not letting me grab the file. There we go. Excel's being a bit of a bear with me here, but you can see that I've got the CSV report there in the background, my quantity 12, my setup time, and my scale factor, and then my overall cycle time. It actually breaks down the part by each toolpath operation as well. But let's take a quick look at the toolpaths themselves. So part of the benefit of doing that estimation, you can have the estimation section basically do a lot of the CAM work for you. And then let's say you get the contract, your customer gets the contract, and they're ready to cut the part on the machine. They've got a CAM program saved and ready to go. So we generate the toolpaths here and create these folders and structures. And then for each toolpath, even though it's created by Cam Assist, we can go in and adjust the Mastercam parameters. So if we wanted to make changes to any of these parameters, we could. We can also use CloudNC's Cutting Parameters Explorer. So if I right click and come down here to Cutting Parameters Explorer, this is a view. So we had a preview of it in the slide deck there, but you can see that I've got my roughing toolpath number 4, the material that I machined. I could actually change that here if I wanted to. I'm down on the aluminum 7075 alloy. So it's taking those parameters. Plus it's taking the machine parameters. So some of these are coming from my machine setup in Mastercam, and the torque and I think table feed max, they're coming from variables that we set in Cam Assist itself. We have the tool parameters and the application. So this is the work holding. So we're assuming on the initial calculation that we've got excellent work holding. So what can I do with this Explorer? I can basically come in and coarsely regenerate those parameters. So if I want to say, be more concerned with productivity, you can see that the feeds and speeds here all update. This is sort of the dynamic view of those variables. So let's say take a look at chip load specifically. If I look at maybe taking my chip load down, you can see all of the other variables balance in this equation to provide good tool engagement as we're doing that job. I can change this view here as well to a heat map that gives us a representation of the tool geometry in those variables. So I could take those and save the operations out. If I hit this icon here, I can come in and actually see those variables. And let's say I just want to change that a little bit before I send it out, and then I can update the operation. So all I have to do on this toolpath now is just regenerate it, and then Cam Assist, those variables that we put in the Cutting Parameters Explorer will be applied to that toolpath. Of course, there is a cascading effect on that next stock model. So when we look at the output here, we've got our flat finishing, our wall making, our hole making. So we're doing all those hole operations. So currently Cam Assist does hole making, including helical boring and drilling. We will be introducing a very preliminary form of tapping in the next release, which we call basic tapping, which will essentially take the whole geometry as read from the 3D model. So we do our inference based on the 3D geometry, and we'll take that diameter. If it falls between a minor and major diameter, we will then it has a tapping tool in the tool library corresponding, we will take that and apply it to the toolpath. So that'll be a separate hole making operation called basic tapping or tapping. Chamfering and deburring. So we put our roughing out of date on that by that recalculation on that one toolpath. Let me just generate this one. So maybe while that calculates, I'll look at another question. So one of the questions was, what are some of the big companies that are using this for production? Of course, we're not really at liberty to mention names of some of our customers, but if you look on our website, for instance, we have some of our investors listed there. They're not only investors, but they're looking at the product and what Cam Assist and CloudNC offers, not only in terms of our product, but how it benefits their industry and their business. So you can extrapolate a little bit there. And we basically talked to almost every major automotive aviation vendor. There's a lot of interest and a lot of people that are taking up this product in their work stream. So what I want to share here on the stock model, so if I look at Op2, so we've got, as we generate our subsequent toolpaths, because we generated machine group 1 and machine group 2 through Cam Assist together, we get a rest machining between those operations. So you can do this in a two-op operation like this, or even in multi-op operations as well. So if the customer only has a 3-axis machine, for instance, if you set up your, let's say it's a cubic type shape, if you set up your 6 sides to machine as 6 operations, but you calculate them in Cam Assist altogether, it will account for the rest machining between those operations and be a lot more efficient. You could do it individually, but it's going to do probably a lot of air machining passes on those subsequent toolpaths because the stock itself is going to be defined as the cube. All right. So again, we've got our whole operations here defined. Let's look at this in Verify. So one of the questions we get quite often is, how does CAM Assist require any special post processors or anything like that? So when it comes to 3+2 operations, the sending out to the post is going to be dependent on, of course, your setup and what you have in your own post processors. But we basically are generating Mastercam toolpaths. We're not generating G code directly. So the working with your post processor vendor, it should work entirely with what you have already. There are, of course, edge cases where things happen, but those are very, very few and far between. So in the second pass there, that bigger. So there's our part in totality. The center ring there, that might not be super ideal, but I think that might have been machined away in Op1. All right. Try to look at the webinar here.
Geoffrey, I think there was a follow-up questions to the what is the ideal application. I think Carl was asking what is the level of precision CloudNC can do.
It's hard to say what the ideal application is because we have so many variable industries using the product right now. But I'd say, like, in terms of the size that CAM Assist can handle, the sort of the dimensional constraints in the computational space are a bit limited to sort of 0.5 meter by 0.5 meter in X and Y, and it really depends on when we can't say put a hard number on that so much because it'll depend on the corresponding tool library. Of course, if you had a very large part full of complex geometry and you were using a very small tool set, you can imagine that the computational curve is going to be quite extreme. And so we could get some timeouts on the calculation from that side of things. But the ideal applications really are, we're geared towards sort of the aerospace type parts and semiconductor parts like we've got showing here today. Does that answer the question? If I probably didn't quite answer that 100%.
Hopefully it did. Otherwise, they can raise their hands to ask later on.
Yeah.
And proceed.
So I've got another part here. So with this part, again, we've got a part in work holding. So the work holding, of course, that's just merged in through Mastercam or brought in directly from your step file import. In this case here, we look at Op2, I've got some soft jaws. So I need to create some soft jaws, and in this case, the part, those soft jaws aren't really made yet. So we've got them kind of brought in as blanks. I'm going to use CloudNC's fixture management tool here for soft jaw. So I'll open that up. So this comes with CAM Assist. I'll select the part, and then I'm going to select my jaw stocks. If I didn't have jaw stocks, I could create them using this tool as well. So I'm going to pick the spindle direction next, and my jaw opening direction. And I'm going to give this a little bit more padding on the material. And check those on. In this case, seeing red is a good thing. It's calculating that that removal. Now if I turn this off, you can see that it's got some soft jaws created there for us. And these channels here are intentional. So if we look at the part itself, we have that slot there that needs to be allow the jaws to open and shut. If these were just round bosses and didn't have the slot here, we would still get that C channel as well, because we'd have to be able to open and close those. So the part geometry can be quite complex for the creating the soft jaws. Okay, so we've got our op2 work holding configured and ready to go. For op1, we're just holding the piece in a vise, kind of as normal. And then I'm going to open up Cam Assist. It's just saying that something's not visible. All right. So on that first one, we ran with one tool library. Let me show you how to do it with the second one. I'm just going to add it in. So I'm going to go to the default location. Mill. And I'm just going to add in the Cam Assist inch library as well. So when you install Cam Assist, you get an inch and a metric library. Just takes a second to load in here. So now I've got two tool libraries here. Like I said, you can get up to 5. If I look at the tool use here, this top now becomes a control to view those two different libraries. So you can see library, the inch library, it has 260 tool assemblies, and the metric one has a few less. We've got a lot of drills in the inch library. And then if we look back on the general tab here, I've got this part. I want to make sure that I've got it set up for 3+2 because of those features on the side. Again, I'm going to just use the align to XYZ. One set up for op1, one for op2. These planes, they can read any of the planes that you have in your Mastercam file. And this avoidance geometry is handy, so we don't really need it in this example, but sometimes what you'll find is that some of the toolpaths want to maybe go into this area a bit too much. And if you create just a simple solid block or any solid shape and select that as avoidance geometry, it works a lot like a fixture does in Mastercam. However, the avoidance geometry will allow you to do whole operations. So we're going to set our avoidance geometry here for those soft jaws that we made. So I'll open up the op2 view here, and I'm going to pick avoidance geometry. So I've got those defined here. The work holding security here. So this basically at this stage controls the tool library a little bit. So just for the demo here on op2, let's say I'm going to my soft jaws are secure, but I'm just going to drag this down a little bit, and the tools you'll see in that list, the maximum tool diameter will change. We'll come back to the tool use here. One other thing you can do here is, let's say, just as an example as well, that this 1.5 millimeter bull nose, I actually don't have it in stock at the moment. I can disable it from Cam Assist just by clicking this, and it'll be bypassed by Cam Assist in this case. And I can do the same for operations. So these are the operations: roughing, flat finishing, wall finishing, and helical boring. If let's say I don't want to use this tool for helical boring, I could disable it like that. Gives you a bit more control, but these don't affect what's happening in the tool.db file, but they are persistent in Cam Assist. So every time you call up this tool library now, it'll have these settings until we make those changes. All right, so let's hit run on this one. And again, we're not going to see the toolpaths come in because I'm back in the levels view, but we'll look at some of the other questions we have. So what are the planned future improvements? We're continually improving the product, of course. So I mentioned the basic tapping feature coming into the next version. We've got another plan. So we've got quite a large number of alloys available in the drop-down menus already. We're going to be adding more alloys to what's available, and also bringing in what we're calling custom materials. So this will take in basically, currently we're doing a bit of hard coding between Cam Assist and the tool manager with regards to materials. So if you need to run your own tool library, or of course you're going to run your own tool library, one of the things that we're getting customers to do now is basically copy the materials from one of those demo libraries back into their own library. We're going to be breaking that up a little bit in the future so that we're actually going to read from the tool library what the materials are there, and then as long as they're set up as a preset in the tool manager, we'll be able to bring in other materials like nylon or other alloys, other metals. So that'll be freeing up customers quite a bit. We hear about that quite a bit. Sort of in the longer term, so we hear a lot about other machining applications. Currently, of course, Cam Assist we're really specialized on milling, and that's 3-axis and 3+2. So when we say 3+2, we really mean 3-axis for 4-axis and 5-axis machines, where the part is put in an orientation, and then a 3-axis toolpath is created for that orientation, and we can have many orientations, of course, but it's not doing dynamic, continuous motion, true 5-axis machining at this point. So that is way far out on our own roadmap, but we do hear a lot about turning. So that is potentially going to be in Cam Assist by this time next year. In terms of precision machining, so I hinted a bit about that the basic tapping is not really addressing the core problem so much as fulfilling a bit of a short-term need until we get to more precision in terms of GD&T tolerancing and using things like the STEP A242 format to take in GD&T tolerancing right from the 3D CAD model, and then applying the appropriate probing and sort of conditional logic in terms of the toolpath generation for that type of output. All right, again, I'm going to hit the yes here to generate a cycle time estimate on this one. And see if it'll let me go back to toolpaths. Kind of seeing things in the background a little bit here, so there we go. Of course, I might turn on the multi-thread manager in Mastercam as well to see sort of the operations being calculated while this is going on. So yeah, and then in terms of future improvements, we want to add more functionality to the other tabs that we see on screen here with estimation and fixture management. So in 3+2 situations, helping the user set up picture frame type of cutouts or snap out type of operations, sort of in a rudimentary way initially, like we have with the Softjaw Designer, but then bringing those processes together so that it becomes more of a single operation to say, here's my part, here's how I want to machine it. Cam Assist, set up the part, set up the fixturing and the work holding, and provide the toolpaths I need to send these to my machine. Same thing goes for sort of bulk operations. So right now we're looking at sort of parts one off, one by one. But of course, a lot of customers operate on pallets and tombstones and use other bulk operations. So that'll be coming into Cam Assist as well. So for the tolerancing on threaded holes, we are offering the basic tapping in the next release, but we are going to be working to make that even more of a robust, high precision tool going forward based on incoming geometry from formats like STEP 8242. All right, maybe while this calculates, I'm going to go back to my other session of Mastercam and talk briefly about the cycle time estimator function up here. So we've been running Cam Assist and then generating estimates. We also have this cycle time estimator, which basically lets you create estimates from Mastercam files directly. So I can bring in a folder here. And so that folder has Mastercam files that have the stock and the machine groups defined, but no toolpaths applied to them yet. In the case of the demo here, I'll just take one of them off. But I can have those sort of in the queue. I can have my tool libraries configured like I had already. I can then, for each of those parts, apply the same properties. So we've been running a lot of aluminum. Let's try stainless, 316. And these are 3-axis parts. So these are very simple parts just for the sake of the demo here, but I'll hit run. It's going to open up Cam Assist and run through those parts one by one and generate the tool path the same way we do normally in Cam Assist, and then take those outputs, put them into the cycle time estimates queue there, and allow us to export out that CSV estimation file. So it's a sort of a quick way to do a bulk operation. Let's say your customer or your customer's customer has sent you a quote. It's got 3 sort of similar parts. You could do it this way, or you could do it the way we did on the other parts where we open them up and actually spend a little bit of effort setting them up and setting some of the human guidance on Cam Assist so that we can get desirable output in terms of not only the CAM program, but the estimation. We anticipate like Cam Assist will get you 70 to 80% of the way there on a lot of complicated geometries. On very simple parts, it's going to be much closer to 100%. So some of the things you have to do and some like the limitations on a Cam Assist output, see those parts have come in now. So now they're in the queue. We've got the dimensions and the cycle times listed here. I can change between the views here too to see those parts. So some of the things you have to do on a toolpath, you might get some output that maybe Cam Assist gets a little bit confused on, or maybe potentially it's not quite how you would do it. So when we take any part, give it to 100 machinists, 100 CAM programmers, we're going to get 100 different solutions on how to machine it. So it might not be exactly to your liking, but you have the facility to edit. The output here is, of course, modifiable. You can change the ordering, you can add operations, you can take operations away, and you can correct operations. But there will be occasions when Cam Assist is identifying that maybe due to the constraints of the tool and the holder, it can't machine all of the geometry. There's going to be some leftover geometry. It will give you a message in the comment of the toolpath as well. All right, let's see how this one's going. So I've got the part ready. It's in the queue now too. I'll come back to the toolpath. Go back to op 1. So you can see after roughing, we're going to be in this state. Then we do our flat finishing and wall finishing and our hole making operations. Are there any other questions in the queue, Kai?
Yeah. Yes, there are a few, but maybe I was thinking for the cycle time estimator, maybe you can try opening up with your Google Sheets. It's a CSV file. You can let them see the output that it shows.
So I actually had one that I did yesterday. Okay, in this case, I took the liberty of doing some formatting on the sheet, but this is the same semiconductor part that we did. We've got our straight up machining time there for the single part at 14, and the setup time with the scale factor. We have the overall cycle time, so 17 minutes for one, 6 hours for 14. We've got our part bounding box here, our part volume, stock size, number of faces machined. So this is another one of those elements where we could sort of extrapolate that I might need to do a bit more manual operation in Mastercam to deal with those three faces. They might be incidental or not important in this case, but that's something that we go and check on. We'll see that number come up right when CamAssist completes as well, that in the dialog that CamAssist is completed, it's done X number of X faces, and that'll give you an indication. Of course, if you're doing maybe a 3-axis job and you're only doing one side of the part, you'd fully expect to be less than 100% of those faces. You'll see here too that for machine group 1, we've got the roughing time, and then broken down by each toolpath, and then the flat finishing and wall finishing, hole making, etc. Same for machine group 2. So it doesn't come out looking like this exactly. It'll come out more like just a raw CSV, but just a little tweak on this one to get the result there. So one other thing that can be interesting, generate this one again. I think these toolpaths got interrupted when I went into the other tab. Oh, a little unexpected. Would be a demo without that happening. But if I look at this one in the Cutting Parameters Explorer, so of course, with different tools, we're going to get different views in the Cutting Parameters Explorer. So this is with the chamfer tool. And you can see that we can control here the depth of cut. So the visualization on the diagram there gives you a good representation of where we're going to set the tool. So typically we want to engage the length of the cutting edge, not the tip, because that has 0 velocity. And then I can use the Cutting Parameters Explorer to help me define that tool visually rather than just numerically. But I can do it numerically as well. I can come in and double click on any of these variables and set them. Are there any other questions?
Yeah, help with the questions here. I think there's one that's quite good. What are the current abilities and limitations? Example, in the material, machines, 3, 4, 5 axis capability.
Yeah, so as I mentioned, full 5-axis, that's a little further out on our roadmap. We find that when we spoke to most machine shops nowadays, even though they have 5-axis machines, 80% of what they're doing is 3+2. So we think that our solution has really addressed that need and helped them to be more performant on those tasks. So basically, if you've got a bunch of jobs in your queue, and some are 3+2 and some are 5-axis, running the parts on 3+2 through CamAssist really frees you up to be focused on those complicated 5-axis jobs that really require full attention. We had one customer, for example, and he was really excited about CamAssist because he was doing all of his CAM programming at night when the office wasn't busy. And so the the program sort of helped him regain a little bit of work-life balance as he could do some of his jobs more during the day and not have to take up his evenings so often. In terms of materials, I mentioned that the materials we have in CamAssist now are defined here. Bring it back up. So we've got aluminum and then the aluminum alloys, and we're going to be adding to that in the next release. A few more. And then in terms of stainless steel, we're adding quite a few more. Tool use. So these materials, and then on the next release as well, we're going to be taking this, the way this list is coming in, and actually reversing it, so it'll be coming from the tool DB file itself and reading the materials that are in those columns itself. So it'll be a lot more open in the future. Currently, we have some customers that are doing things like if they're machining plastics, they will use the aluminum settings and override them a little bit to their own needs and specifications. And then in terms of the cutting parameters, so some of the tools, the cutting parameters Explorer is limited so far to round solid tools. So when we're talking about face mills or other indexable tools, they're not going to be set up in terms of CloudNC cutting parameters quite yet. So we're going to be taking some of those. The CamAssist will run with them as long as they're set up as a preset. So by preset is basically in the Mastercam tool manager, we set a cut parameter. So I know the terminology gets a bit confusing because we're saying cutting parameters, and then for the preset is a cut parameter, but that's kind of how we set it up. I can show you a quick example here. So this is the CamAssist metric tool set. Wait for Mastercam to catch up a bit. So we've got those materials. So here they are here, same list from CamAssist. And then we set up our tools in sort of the following way. So they're numerical for the cutting tool, a matching number in the holder, and then in the assembly, pardon me. And then in terms of the cut parameters here, we look at, let's pick an end mill. So this one here, 14201, pardon me. We've got the material defined and the surface speed and feed per tooth. That's what's defining the preset. That's what CamAssist is reading and putting the blue border around the AL in that case. Let's say we wanted to take that tool and in our own library and have it use that for a different material. We could duplicate that finishing and the roughing as well. And then we'll take the material, switch this to stainless. Same over here. And then we can put in our tool vendor recommendations here for feed per tooth. We'll just make it kind of coarse. And the same thing on finishing, just kind of roughly by half. And then CamAssist will take those variables. So let's look at 14201. I have to reload it just to remove it. Change this one back to the metric. So there it is there. For aluminum, if I look at high carbon steel, it doesn't have a preset. And then if I look at stainless, it should have the preset again. So we use that blue border to show if there's a preset. Again, you don't really need to worry too much about presets because Cam Assist can generate the cutting parameters as well. This slider here is what that we saw that in the Cutting Parameters Explorer, where we could have this slider go between productivity and tool life. Let's say I want to run this whole part right at product, slid up to productivity. I could set that and then sort of preset all of those cutting parameters to be more on the productive side as they calculate.
Okay.
All right.
Another question. Let me combine these two questions. It's quite linked. Is it a true AI or just a predefined database? And then there was a second question it asked. Does Cam Assist come with self-learning feature? Can it be trained by the user? So I think it'd be good to share about the whole AI model you guys are using.
Yeah, so it is our own AI model. First of all, in terms of machine learning, it does have machine learning characteristics, but we're not doing machine learning on parts or tool paths at this point. Now, in Mastercam, that's explicit to the end user license agreement that we do not do machine learning on your parts. The only thing that we save when we send the file up to the cloud for computation is a log file of the event. We cannot regenerate the geometry or the toolpaths from that log file at all. It's just using the cloud for the intense computation that it needs to do this process. So how do we train Cam Assist? Basically, we're building in rules into the system that govern how it decides how to machine something. So we're basically training our AI to think like a machinist. So it's using statistical machine learning that is basically a hybrid of stochastic and probabilistic statistical inference models. I know that's a bit of a mouthful, but it's our own internally generated patent pending technology that we're using, and it's not doing things like Chat GPT, where it takes millions and billions of tokens for words, and then basically does sort of the next word in the sentence matching. It's not doing that quite. It's doing it more on I've got this tool geometry, and I know that for this part of this model, I need to do a hole making operation. I'm going to look at my drills. I can't drill that hole. I'm going to look through my end mills to see which is the most appropriate for helical boring, and then I'm going to actually compare those tools to the rules that are defined for those operations. For instance, on a flat finishing operation, I know I'm going to use an end mill, but I know that stick out of that tool cannot be greater than 4 times the diameter because I'm going to experience too much tool deflection and I'm not going to get a good surface finish. So I'm going to try out the next tool. And it's running through that millions of times on each part. So how do we train the system? How do we define those rules and make them better over time? We listen to our customers, we listen to our resellers, we have our own factory. So in the slide deck there, I have the picture of our shop, and when the Thea was walking through it, we're using that factory to continually experiment and improve our models, and that includes everything from the cutting parameters values, and so we have machines hooked up with sensors and all kinds of equipment to determine the tool deflection and ensure that our models are appropriately creating the tool paths for maximum efficiency, and also just getting feedback from our application engineers on, or customers. Cam Assist is doing situation A when I have these conditions. I would expect actually condition B, or sometimes in situations like that, we'll get to the point where there's no right or wrong answer, there's alternatives. So we'll have to do things like give the user a choice. In terms of freeform operations here, we have waterline or hybrid. So waterline is great for some situations. Hybrid is good for certain situations. we've got plans to implement other freeform operations like scallop into this list, so that Cam Assist will prefer one or the other based on the user's discretion. That's how we kind of build it in. And then over time, we're getting kind of smarter and smarter with the operations that we're producing. Hope that answers the question.
Okay, I'm mindful of time. It's 5 p.m. We have two questions I think can quickly answer. The first question is, do you all integrate with VeriCut?
Not directly, but we of course, a lot of Mastercam customers are using VeriCut to check the toolpaths that Cam Assist generates.
Okay, and I think the last question, there's a question about if they don't have the work holding input, is Cam Assist able to work effectively? So yeah, in terms of planning out the work operation and so on and so forth.
Yeah, so of course, in these examples, we're always including the work holding to be kind of correct. But if I wanted to bring in a model here, let's bring on that first example. It doesn't have any work holding attached to it. I could basically run this without the work holding and just use sort of the constraints of the model and the stock to define that. So let's just do a quick example here. So first of all, I have to set up a machine group. And I'll get the stock defined. So number one, I need a master model. And number two, I need my stock. So the stock that we can use in Cam Assist right now is basically a bounding box or a rectangle. We're looking at how we can implement cylindrical and mesh stocks. I've got that defined. And I'm not going to skip the work holding on this one. And then I'm just going to, in Cam Assist, we'll say that it's a 3-axis machine. I'm not going to do those side holes in this operation. Three-axis from the top, just hit run. So I actually meant to give the stock a little bit more height in Z to account for that, but you'll see that we could, depending on how we had this set up on the machine, we could probably run this quite safely without defining the stock and bringing in all the devices and things like that into our Mastercam file. I'll say no in this case. And I'm going to say, so if I say no, I can say no here, and I'm not going to generate the toolpaths in Mastercam, but then I can come in and sort of check them one by one. Sometimes when you get dozens and dozens of toolpaths all at once, it helps to just sort of do it a bit more step by step. You can see here that I'm not going through the bottom to any great extent. So if I had my stock high enough above the vise, above my work holding, above my vacuum table, I'd be safe.
Okay, thank you for sharing. I think there's no other questions. Thank you, Geoffrey, for your time. Not sure, you have another meeting you need to run off to?
No, I'll hang around. It's very interesting, and thanks for having me, and thanks everyone for joining today.
Thank you for coming. So anyone else have any other questions? If you have a burning question, you can raise your hand, you can actually speak and ask your question also. Some of the other questions Hans has been helping to answer. 2 diameter, do we need auto generate or need to do the setting? I think as Geoffrey showed, you need to still set up your tool library. You can't auto generate a tool library.
Yeah, the AI is not quite a mind reader or at the point where it can read from what's in your carousel at this point.
Yeah. And the next, another one that was answered, does it only work with specific machine makers? Does it run on Makino yet? I think as Hans mentioned, as long as your program can run, it can run on any machine.
Yeah, that's correct. We're not limited to machine constraints too much.
Okay, so if there's no other question, then we'll end the Q&A, and then let me continue on my end. Sharing. Share my screen. Hope everyone can see my screen now. Okay. So in terms of what Cam Assist can do, I won't go into more details since Geoffrey has already shared so much. But as a summary, I guess these are the highlights that Cam Assist can bring you. And this is done through the various features that it brings to path generation, your cycle time estimation, and your fixture management. Wrapping up, I would like to share some takeaways on, I guess, AI co-workers within our whole manufacturing scene in Singapore and I guess worldwide. So looking at AI, I think the whole point is to scale your business without scaling headcount costs. The whole point is to augment your staff workforce as you expand your business. And for those programmers here, the whole idea is that you guys won't be. The whole point is not to replace the engineer, the programmer, but to improve the human capabilities. So in a sense, humans won't be replaced by AI, but by those who use AI in the future. And hopefully you guys can leverage AI to reduce your training and process costs, be it to onboard the new staff on the programming knowledge and the processes. And looking at AI, definitely it is increasingly affordable. This AI coworker, we can get it at a fraction of your human staff to help augment the capabilities of your staff and providing up to 80% cost savings for your scale your operations. Okay, so that's it for the Cam Assist AI parts. Moving on, I'll just share a bit of promotion on the Mastercam side. So this was what we shared during rollout. So if you know, if you went, this will just be a bit of a repeat. So up till the end of the year, we're running this campaign of 10% discounts for basically everyone involved. If you are an old customer with us, you have a maintenance agreement that has already lapsed. You can have a 10% discount on your maintenance reinstatement. If you're a new customer with us, you can get a 10% new account incentive. And of course, this is not applicable if you're applying for the PSG because there will be at a higher discount rate of 50%. And actually, this also applies if you are a business and you have actually opened a new location, new office, you also be eligible for this 10% discount. And lastly, in terms of our existing users with existing maintenance, you are on Mastercam 2025. This year at Aurora, we also launched Mastercam Deeper, which is add-on that you can add to your Mail 3D. They can add the debug functionality to your Mastercam software. Okay, moving on. Good news for our new and old customers who are joining us who have not applied for the PSG grant. Our grant application has gone through. So starting from 7 November, we will be back up and available with our PSG grant. So do contact our sales if you are interested to find out more, especially if you guys have been waiting for quite a while. Okay, and lastly, our last event for the year before we wrap up for the Christmas break. We'll be going to Thailand for Metalex 2024. So if you're there, do come to our booth to say hi. Okay. And then that's it from me. And before you guys go, do help us to scan this QR code to fill in the feedback form. And this will be where you can request for follow-up from us for be it for Cam Assist, for Mastercam and PSG Go and so on and so forth. And it'll be good to give us some feedback on how was this whole session, and if you like it, we'll do more of this. Okay, and I think that's all. I'll stay on this page if you guys want for you guys to scan the QR code. Let me just send a link into the chat and to make it easier for you to exit this for a while. Okay. Anyone have any other questions? You can still feel free to ask. I've left the QR code into the chat. Okay, let me share my screen again. Yeah, you can access the survey form from the chat itself. Okay, otherwise, thank you all for coming. We'll be hanging around. If you guys have any other questions, you can leave on the chat or raise your hands. We'll be here to chat. Otherwise, if you're busy, you can feel free to drop off. And otherwise, thank you, Geoffrey, for coming. Yeah, we just stay on here. You can see some people dropping off.
Thank you.